Well, welcome everyone to the next episode of DC Thursday. We have a really awesome episode for you today that I've been looking forward to for a while. And most of you, many of you in the community, maybe most of you have heard of the Great Expectations data testing framework. And so our guest today is one of the co-authors of the project. I'll introduce him in a second. But Great Expectations is an amazing open source tool that you can use to test the data flowing through your systems. And the project debuted at Data Council, I think it was in early 2019. And we've been tracking the project for a while. So we've seen a lot of their growth. We've had the co-founder and co-author Abe Gong on the show before. But our guest today is James Campbell, who's another one of the brains behind the project. And James and I are looking forward to having a chat about not just an update on Great Expectations, the project. There's some new cool features that we're going to talk about, including profilers and extensibility. But we're also going to talk about James' background as an analyst in some interesting sectors. And so, James, I'm really excited to welcome you to the show.
Thank you so much. I'm really excited to be here.
Yeah, it's great to have you here. And you have a really interesting background, so I want to get right into it. You were an analyst in several different types of roles, and I know that includes even some work for the NSA, which you may or may not be able to share with us many details about. But I'm curious to hear a little bit about the early part of your career and how you got into data in the first place.
Absolutely. I was reflecting as I was thinking about this conversation on what the trajectory for me has been, and I think it's really there's a really interesting dynamic where, on the one hand, I've gotten to see a lot of change and, like you mentioned, move between different roles, and I can mention a bit about that in a second. But there's also been a very direct trajectory in some ways. When I go back to thinking about my academic background, I actually recently looked at my college application, and they asked the question, "What would you want to study?" And I said, and at the time, everyone is kind of canonically uncertain, but I marked down math and philosophy because that's what was the interesting area for me, that intersection, and that has really continued to be true for me. That is what I ended up studying as an undergrad, even, and then throughout my career, I've gotten to move between more quantitative and qualitative analytical roles. Right out of college, I worked as a economic analyst. We were doing mostly securities litigation, expert witness testimony, and then I moved into the intelligence community, like you mentioned, and getting to rely on some. I was really lucky to have fantastic mentors when I was very young, and get to work in networking, and so I moved into computer security, and as that became something that we had a tremendous amount of resources in, I got a chance to grow, I think, with the zeitgeist into the big data movement, and experience the perils, but also the joys of getting to work on those kinds of problems.
And now, of course, you're the CTO of Superconductive, CTO and co-founder, which is the company behind Great Expectations. How did you discover that you wanted to start a company as an engineer?
I think it was interesting for me to think about the prospect of leaving government. I have always been really drawn to public service, and so I love that aspect of work. But again, in that kind of trajectory comment, I think I remember being very interested from a young age in the challenges of entrepreneurship, and in many ways the problems are very different because we're more resource constrained in some ways, but also the opportunities are different. We have a lot more ability to just be out in the community, and being part of an open source project is not a way that I even realized would have been possible in terms of starting a company long ago. And it's been really phenomenal to just see how much community engagement and interest and contribution there is.
And how did you get interested in open source projects or sort of get involved in that space in the first place? Is there a story there?
Well, I've always, I have had, interestingly, maybe software engineering was always for me more of a means to an end. I mostly was learning and doing coursework focused around being able to solve particular problems. Whether that was cybersecurity questions and take advantage of novel data sets, or the economic analysis that I mentioned earlier. For me, I think the benefit of open source was therefore just apparent throughout my career, because I remember working with Hadoop when it was literally, we had some old computers under a desk trying to figure out if we could process more log data. And the idea that we could take advantage of so much really impressive thought and work that a huge community of people had contributed to was always really exciting. And in my last role in the government, I was with a lab called the NC State Laboratory for Analytic Sciences, which is sponsored by the intelligence community, and where our explicit goal was to reach out and engage more broadly with the community to make sure that the best minds in the world were working on the kinds of problems that we were interested in. And so again, I just felt like I got to see what incredible things can happen when you harness the power of an incredible community. And I never think dreamed when I started working on Great Expectations that it would become the project that it has. I was looking just the other day. There are well over 100 different people who have contributed substantively to Great Expectations, and representing companies big and small, students and professionals, and we know, of course, for every contributor there are many, many more users. So it's been really fun to see that.
And I find the origin story of the company, and the project, both sort of equally interesting. Of course, Great Expectations is the open source project, and Superconductive is the company behind Great Expectations. But you and Abe started off doing consulting, correct? And Great Expectations, the open source tool, essentially fell out of that work as you were looking for repeatable ways to do things with clients. Can you talk to us a little bit about that and a little bit more about the origin story specifically of the Great Expectations project?
Sure. It's actually, it's even more serendipitous than that. In fact, Abe and I have known each other since we were very, very young. Our parents had studied together in the Bay Area in the 70s. And we were in different areas. He was working in the healthcare space. Abe is through and through an entrepreneur and had worked on a number of different companies already. And as he was really interested in making changes to the healthcare space, he saw the same problems that I had experienced in the intelligence community. And just by virtue of having been friends for a long time, we had a routine call together, the two of us and several other people that we knew, and we were talking through things that we were interested in. And I said, I'm going down to this lab where I can pursue my passion in many ways, and this is one of the things I want to work on. And he said, no kidding, I've been working on the same thing. So we began collaborating, for me as purely, exclusively on the open source part, not engaged at all in the contract, while he was doing that. And then it's only been since I joined the company about 2 years ago that we've, and then actually only about a year ago did we decide to really pivot fully into Great Expectations instead of the consulting side.
Well, that's a great founding story. It's always illuminating to understand the details and the circumstances surrounding how two founders met, because I know there's lots of engineers in our community who are looking to start companies, and that's one of the things that's exciting to me about getting folks together at Data Council is I don't just want them to find career opportunities or jobs or get smarter or discover open source. I like them to start companies when they're so inclined. And so being able to match founders together is one of the exciting things that comes along with that.
Yeah,
So
you certainly have a gift for bringing people together.
oh, thanks. I'm excited to, for mass vaccinations to roll out and for us to be able to run in-person events again for sure, because, it's great to see people in the video Zoom screen, but it's not exactly the same, as we all know. Well, that's a great sort of background of the company and the project. The other thing you mentioned that's just intriguing to me that I have to ask about is the intersection of math and philosophy. So before we move on from your background, is there anything you want to say about encouraging people to get a philosophy background if they actually want to go into data?
It's funny. I think long ago there was a huge pipeline out of philosophy departments into software engineering in the in the 60s and 70s, and I think there's always been a really deep link between computing and philosophy, whether that's a lot of the 20th century analytic work and work on fundamentals of computation, or what's been or I shouldn't say or and what's been particularly interesting to me is in the space of really understanding confidence.
Mm-hmm.
And so I think there's actually a way that we're seeing that is as a huge resurgence that absolutely, to your point, really calls out for a more need to invest in philosophy, and that's in the space of explainable AI and ethics of AI.
Mm-hmm.
As models become more complex, but actually, I think just as important as the relationship between the construction of training sets and the influence of that training set on the population becomes more pronounced. In other words, where you can no longer assume that there's independence between the predictions generated by Gen 1 of a model and the training data used for building Gen 2. We need to, I think very carefully about what we want the system to do. And in fact, in many ways, that's the philosophical side of Great Expectations. When I've talked a lot about what we're trying to do, sometimes I use the phrase analytic integrity, meaning really understanding with a lot of precision how confident we can be in the judgments of any given system, which will depend on the characteristics of the system, but also of the environment that it's located and operating in.
Mm-hmm.
So
Mm-hmm.
yeah, I could go on forever about that, but I love the way to frame it. Like, absolutely, I think there is tremendous value from being able to draw on the work that has come before us in thinking about those kinds of problems.
Yeah, perhaps it's valid to say that philosophers like to think in terms of frameworks. They're establishing a framework for a way to see the world. And it's probably not too far off base to think of GE as establishing such a framework and a language and abstractions and all of these notions in the world of data. So, of course, some people just might say that they're both black arts, data and philosophy, but I think I can understand maybe some of the esoteric connection there. So I think a lot of folks in the community are already familiar with GE, but just before we get into some of the updates and some of the really cool features that I know we want to spend a bunch of time on, can you give us a quick background of the project, what it does, the main components of it, and how folks are using it currently today?
Absolutely. So Great Expectations is at its core about helping people express expectations about data and verify that those expectations hold on data sets. So data quality is really what we're about, but quality doesn't mean that it's pristine in any particular way. Quality is always tied to the purpose for which it's being used. So it's about being able to draw that line. One of the things that we're really committed to, like you mentioned earlier with Great Expectations, is being a language, a way of communicating. So Great Expectations provides a mechanism for users to declare expectations, which can be things like, I expect a column to exist in a table, or I expect values in a column not to be null, or I expect values to come from a particular set that we've agreed on with the product engineering team. But they can also be related to aggregate characteristics. I expect the mean of the values in a column to have some value or be in some range, or I expect the distribution of values in a batch of data to fall in some range. And because we're in the business fundamentally of being able to declare and then test expectations about data, we have a really natural way of presenting that. And so we call that data docs. And so one of the key features that Great Expectations offers is the ability to visualize what the expectations you have are in a prescriptive way. So, the data in this or the values in this column should not be null, sort of a normative prescriptive statement. But then also in a descriptive way, like there are 50 null values in this column. And then finally putting those together in a diagnostic way. So you can get a pretty web page that says there should be no null values, but there were 50 null values, warning. And then you can tie that into an alerting system that runs together right in your infrastructure. So we have a lot of users who, for example, deploy Great Expectations in their Airflow pipeline or in whatever DAG runner they use, Prefect, Dagster. There could be a cron job, and they get this diagnostic report about whether the data that they are processing meets expectations. So that's really what GE does. It really helps you declare and think carefully about what your expectations for data are, and then validate that they're true.
Got it. And how many folks do you have using GE at the time? How do you think of the size of the community? And I know it's a growing open source project, but are there specific things that you get excited about in terms of KPIs or metrics, or how do you think about that, and then the impact that you're having on the community?
Great question. And that goes back to our comment earlier about just being excited to be part of an open source community. It's very difficult as an open source library to say with confidence how many users there are, because there are lots of users who we probably never know about. But we're really focused on building community. So a couple of the KPIs that I would flag that I think are indicative of that is we have over 1,000 users in our Slack community now. And we see job postings routinely in there. People can advertise their problems, and then of course there's support for GE of course in the community as well. But
it looks like you have 2,200 people in your Slack community.
Over 2,000
as of right now, because I just signed in to check it out, and I see over 2,200 people. So just a heads up, the numbers are even rosier than you thought.
Well, I'm underselling that. Well, so that the other way that I think we measure community, and I mentioned this one earlier, is just the number of actual contributors into the code base, which is 100 already. It's over 120, I think. In fact, let me try and redeem myself on the site. I think it was 126 when I looked last week, and I know for sure it's gone up a little bit since then. So anyway, those are the measures that I get most excited about. But of course, there are other ways that we do have some instrumentation in the library that helps us sort of see how many validations are being run and that kind of.
Got it. Well, this is a good place to mention to folks who are listening that we do want to take questions for James in the chat. So if you have questions for James about his background or experience, or about GE itself, the project, feel free to pop them in the YouTube chat, and we'll do our best to get to them as the show unfolds. So James, I think we understand what GE does, some of the origin story. Maybe going back to a higher level sort of concept, surrounding design principles, I'm curious how you guys thought through what you wanted to accomplish in the GE project, because I've always been impressed at the thought that's gone into the structure of that framework and of those abstractions. You guys are very much abstraction designers, and in conversations with you and with Abe and even with the rest of the team, some some of whom met together at Data Council, incidentally, which is another cool story. The team's always been like very thoughtful about the way they've rolled things out. So as an example, I'm curious if you can sort of explain to us some of the design principles behind the project and how you prioritize trade-offs and what things you cared about. If you could walk us through some of the main thinking in terms of how you thought through the project design, that would be super interesting, I think, for our audience.
Well, firstly, thank you. You know, it's really been fun to get to have a community that we can discuss these things with. And I think one of the things that's really helped with that kind of approach to design is that we haven't been exclusively focused in one domain. And so one of the design principles is that we want to become a language. We want to be declarative and expressive. That means that we often use very, very verbose names. One of the expectations that I remember, you know, when we were just thinking through how should this work, was we described literally in excruciating detail, in the name of an expectation, what statistical test we're going to run, and then the parameters become the parameters to the test. So again, that kind of transparency and verbosity are things that are really important for us and for our users. And then as we've been able to do more work in renderers, and we can talk about that a little bit more later, but more work around the data docs, we're really focused on making sure that we never lose hold of exactly what's happening and exposing that to users, on maintaining our credibility first when we're doing any kind of new expectation. Another thing that we really are focusing on is making sure that the prescriptive or descriptive or any other way that an expectation is presented, it's understandable to as many users as possible, and ideally at different levels. So we want to make it possible to look into the result of a validation and get a lot of detail, while also being able to get a summary if that's what's relevant for you. So making it easy to structure the information right away. That's on the expectation side. Interestingly, I think some of the most challenging design decisions that we've faced have been around how we interact with others' infrastructure. You know, there's a real interesting tension where Great Expectations is definitely doing compute, right? We're computing the mean of a column, or we're computing whether values match a regex, you know, using some other engine like Pandas or your database or Warehouse or Spark. But we also don't want to become a tool that is used for transformation. We need to have our tests live really close to the raw data. That's how the value comes. You know, what we really offer people, I think, is the ability to understand what the data is that they are getting, as well as what the data is that they are emitting. In fact, that's one of the, I think, really subtle design questions is what exactly do you test? And I think often we find that testing your inputs is actually more important than testing your outputs. Great Expectation. In terms of, I don't know if important is the right word, but it offers more insight often to the data team. And of course, eventually, I think they usually mature into doing both, but in terms of getting started.
So is that to say that you're trying to stay distant from transformation processes, and you're sort of very conscious of trying not to blur that line or not encourage your users, as the case may be, to blur that line in their own systems?
Yes, that's exactly right. Now, again, you know, what we are doing is we are introducing some of those capabilities, but we're doing it in a very, very measured way. And going back to the point about, you know, philosophy, when you think about the expressivity of a computing system, there are several pretty clear inflection points. Like, at what point do you allow somebody to defer computation or provide a parameter, you know, use a variable instead of a parameter that's known in values? At what point do you fill these variables in? Also, at what point do you provide for condition in the flow of computing? At what point do we allow grouping of data? And so we've been introducing those concepts in a very careful way so that we never lose track of being data quality. Like that is a core promise that GE offers.
Hmm.
And again, just to hit on that, on the last thing I was saying with respect to integrating with DAG runners. So we absolutely want people to be able to test data in whatever transformed state it is. And so we've done a lot of work about making sure that we also can be really clear about what has been tested. So the concept of a data source, a data connector, a batch, what exactly is running. And often that confuses people, who hear batch and they're like, well, can we use GE on streaming data? And the answer is yes, for exactly the reason that we were just describing, we provide multiple lenses into any given set of data so that you can evaluate it for the different purposes and in the different times and places that are most relevant.
Mm-hmm. Got it. And along those lines, I'm sure there's different philosophies of so-called anomaly detection. If you think about sort of the broadest category that maybe GE would play in, how do you compare and contrast some of the ways that GE approaches this field versus other projects or other models that you've seen?
That's another one that I really love as a question because it lets me be philosophical, and a lot of people ask that question all the time. I think the biggest way that I like to think about the difference is that with GE, there's a huge amount of intentionality around exposing to the user clarity of what they are ultimately testing. And I mentioned that question about what point parameters get filled in. And so I think you can think of anomaly detection as so firstly, just, you can absolutely express basically any kind of anomaly detection using the language of great expectations. But what we're really excited about is the way that we bring clarity to what it is that you're testing. The other thing that's really different, or maybe, so, we can dive into that in a bit later, actually, because we're doing some new work in that area. But the other thing that's just always been really different is, and I sometimes like to use the term out of band for this. So we bring out of band information, meaning we're testing data using knowledge and insights that you as a data team have derived from outside of the data set. The knowledge of what the acceptable values for some code field are, in general, doesn't come from inspecting the data set. It comes from understanding the system that's populating that field. And so we allow you to bring that conversation with your colleague into your understanding of the data and into the testing for that data set, so that you're not relying exclusively on anomalies in terms of deviations from what has been observed past, but more in a fuller sense of the word anomalies, meaning deviations from what could properly be expected based on the behavior of the system.
And how exactly does that work? Can you give us like a specific example of how one might sort of translate a conversation sort of into the from a different business unit sort of into the GE code? Like, what does that look like? What does that really mean?
Yeah. Absolutely, and in fact, I'll pick an example I think that really highlights a lot of the value of GE, because we can sort of play around with at what point that conversation happens. So, I mentioned that I did a lot of work on banking data, and in banking data, it's common to have a given transaction broken up into different codes, and so maybe there will be the total value of a transfer between two accounts, but also what was the cost basis of that transfer, what portion of the transfer is taxes, whether there was withholding that happened. So there may be a number of different rows as with particular codes. Now, let's suppose that a company offers a new feature, they offer a new product, and they choose to encode that with a new code in this data set. Well, there may be a huge number of dashboards throughout a large organization that rely on the data. And so, for example, if you have financial data where we might assume that one code is the total, and then the other codes represent a breakdown of that total into subcomponents. if we add a new categorization or new code or tax law changes or there's a new regulation, any dashboard that relied on basically summing up the values of some set of codes would break. I mean, it would be subtle, right? It wouldn't be obvious, but in some subset of the transactions, you would lose fidelity. So the way that conversation might play out is, in a lot of organizations I've been, maybe a data team would basically send out a big email. Well, we're changing this system. We're, starting on March 3rd, we're going to add a new code, update your system accordingly. And you hope you get that note. With Great Expectations, you could have put a test, and you still can put a test around, well, I expect the values for this code to be exclusively drawn from the set that I'm summing over. And that way, as soon as a new value appears, you'd immediately get an alert about it. But you're not learning that from the data, because your other systems aren't relying just on the data. Right? You've got a dashboard or an analytic system that knows what those code means. Right? They're actually semantically meaningful to it in a way that another anomaly detection system may not be able to take advantage of.
So, but this is a way, just correct me if I'm wrong, but this would be a way of detecting when a value in that new code emerges, not so much a schema validation of whether or not the new code is sort of required. Is that an appropriate distinction?
Yes, that's definitely true. Now, just like you can express anomaly detection, you can express schema validation with GE. But yes, in that example, you're absolutely right. It's really about understanding changes in a complex data system.
Got it. But
and everybody's system is complex, whether they know it or not.
Right. Well, isn't that true? But you indicated that you can also sort of describe schemas and enforce schema validation in GE. How does that work, briefly?
So just like we had, I mentioned this values in a set type of expectation, there are expectations about the storage type of values in a column, the names of columns, orders of columns. There are uniqueness. We could expect column values to be unique, for example, to express a uniqueness constraint in a schema. So it's really about what the expectations that you encode are. One of the things that's really neat about that, and this is something one of my colleagues has been working on just this week, is that you can translate expectation suites between different environments. So you can express a schema that normally maybe would be, normally you might express a uniqueness constraint in SQL as a uniqueness constraint. But that's not something that a CSV parser exposes. So if you want to be able to verify that a new piece of data matches your schema even before it's been attempted to load, so you can get a very detailed report about what's going on, Great Expectations is great for that.
Great, that makes perfect sense. Well, I want to talk about some of the new cool stuff in GE as well, because you guys have been really busy at work. I've seen some great updates fly by. Talk to us about what's happened in the last few months and sort of what the main categories are of work that you guys have been doing.
You're right, this is really exciting. So the main area we've been trying to improve is, well, I shouldn't say the main. There are several areas. We've done a lot lately. So one of the things I'll talk about is the modular nature of expectations. And this is really about making it easier for users to contribute custom expectations and manage custom expectations. In fact, I'm going to be doing a deep dive into the real guts of modular expectations later today. That'll be available as a webinar.
Oh, great.
Thank you. So with modular expectations, what we're doing is taking all of the logic about an expectation, meaning what metrics it relies on, how those metrics are evaluated and compared, what it needs to return, how it should be rendered in those descriptive, prescriptive, diagnostic ways, and potentially in other languages as well. And we're encapsulating that into a modular unit, a Python class that can be imported at runtime dynamically and registered and made available during validation. And so what that means is it's much easier for people to encapsulate all of the logic of their custom expectations, which people have been writing in great expectations from the very beginning, into something that's portable and shareable. And so as a result, we've actually just launched a new package called Great Expectations Experimental, which is built out of a contrib module in the Great Expectations repository, and where we really want to open up to the entire community the ability to add expectations of whatever form they want, and really make that easy. One of my colleagues, Eugene Mandel, has been doing a lot of work around building up templates and guides and documentation for making it super easy to contribute and author expectations. There are also some really fun performance improvements that we get as a result of this modular shift, because it allows us to store metrics and more easily express relationships between batches and so forth.
And do you have a mechanism for the community to contribute their expectations back to some kind of gallery? Or I'm not sure if I've heard anything specifically about that, so I don't want to.
Yes, well,
I don't want to,
You just broke the launch announcement. I don't think we can. Well, so you're definitely in the. We have not launched the gallery yet, but yes, exactly. One of the things that we've done as well as all the things I mentioned in these expectations, is we've provided some mechanisms for you to add metadata. And some of test examples, for example, that are rendered into a really beautiful, accessible page, so that you can search and find others' expectations, create them, and see them yourself. Like I mentioned, this repository is now published directly on PyPy already. It's available for people to contribute to with a really low bar. We have literally templates for expectations. So lots more in that space. What I was mentioning is kind of the guts that made that possible, but you're exactly right where we're going.
Very, very exciting. Well, we'll be waiting with bated breath for some official announcements in that capacity when the time comes, hopefully soon.
Yes.
Well, the expectations extensibility sounds really exciting. Have you seen some good uptick in interest from the community in that so far? I'm sure you get early users in the Slack channel, and you get early feedback from folks. So I assume the response so far has been positive.
Yes. We've still marked that API as experimental. And so we haven't been encouraging people with production deployments to move over yet. But what we are doing is we're actually sponsoring several hackathons over the next few weeks, where people who want to contribute expectations can have a live support from somebody on our team and pair together with others. So it's really, bring your idea, bring what you want to be able to express in the language of great expectations, and we'll help you make that possible.
That's great. Well, count on us to help you spread the word to the community, to our community, when that time comes. So if folks want to watch the Data Council newsletter or the Great Expectations Slack group, I'm sure they'll be hearing about those hackathon announcements soon.
Thank you. Absolutely.
So what else? I know there's more than just the extensibility. There's I've been hearing stuff about profilers, plural, which is interesting to me, and I kind of wanted to ask you about. I've been hearing things about well, you mentioned these new batch style data connectors. You mentioned it briefly just a few minutes ago. Talk to us a little bit about these aspects and what that means.
Absolutely. So for batches first, I think I mentioned this idea that we're making it possible to have a variety of lenses defined into a data set. With the new style data connector and batches, Great Expectations will really help you manage the promises around relationships between batches more easily. So one of the things that people really like about traditional anomaly detection systems is, in some ways, it can be a very useful black box. Put it on a data set, ask it to watch a number of metrics and say, did these metrics change in a surprising way? It's a really useful feature. So in order to make that easier for people to do in Great Expectations, what we've done with batches is provide a really strong sense of ordering and partitioning of batches of data, so that with a data connector configured, you can define different ways to slice a data set, whether that's a load time, or whether that's a date key, or whether that's some other key that's relevant for dividing up a data set. One of the things that does, to get to your other question, is unlock much richer profilers. So you said why plural? Well, because there's not just one way to learn from a data set. And so what we're doing with profilers is making profilers composed out of rules that users can author. And then it's possible to just combine those rules in different ways. And so a rule might be something from your organization. Like, I know that we have a convention where any column that ends in _DT should be a date time. Or it could be that any column that has the term ID in it needs to be unique, or whatever the conventions or things that you have in your organization, that kind of out of band knowledge. But they can also be things that you learn. Like, we've done some interesting work around semantic typing, meaning looking at estimating what kind of data is in a particular column based on its cardinality. If there's every value is unique, it's much more likely to be an ID, whereas there's only a small number of values, maybe this is a code linked to something else. Mm-hmm. Mm-hmm. So with profilers, what we're doing is making it possible, again, to decompose what your knowledge is into rules. And then we're providing users several profilers that also are able to look across multiple batches, so that you can generate expected metrics based on much more information than you could have previously in Great Expectations.
Very interesting. I want to go to a couple questions, because we're getting some questions from the community, and I think they may have to do with some of this functionality. So Brian is asking, I've been meaning to ask your team about a feature I've been looking forward to. The feature is to make it easier to do comparisons between two batches of data, example, month over month. Is this the sort of behavior that you're referring to?
Yes, absolutely. So for a long time, we've had what are called evaluation parameters, which allow you to defer the identification of a particular expected value till a later time. And so in the past, that's how users have handled this month over month problem. They validate 1 month's data, and then they use an evaluation parameter that describes that observed value from the previous month. It's pretty clunky, to be honest. I've never loved it. It works, but it's not really what we were wanting to do. And the reason was it wasn't really clear how to describe that concept. I mean, it's very natural and intuitive for us. What does month over month mean? But for Great Expectations, we needed those promises of the data connector that provides an ordering of batches, so that we can say, okay, we now have a data connector that produces monthly batches. And if I look at we use the term partition, like I mentioned, and then partitions have an index. So you can just say, give me the previous index of partition. Now, truth in advertising, all of the machinery is in place. We have not kind of packaged that up as a feature. We're planning to bring that out together with profilers, so that the kind of functionality is completely baked in there. But absolutely right. That's exactly where we're going, and I'm glad that jumped out at you.
Got it. I think it's related to another question from the Wi-Fi. I imagine GE is very helpful when ingesting third-party data, as it could flag deviations in input data over time. How have people used GE to perform holistic integrity checks on one source and track how the source changes over time? It seems like this is a similar type of use case, as far as I can tell. Is that right?
Well, yes, although I think often this is even a more traditional GE use case. This is very much the one we were describing, where there are two teams involved. My favorite way, we had one team that talked to us about what they use GE for is kind of writing that awkward email to a vendor. It says, well, you said you were going to give me this, but I looked at it and it's not like that. And that could be, it's a tough email to write because, you need to be precise. Well, GE makes it easy to be precise. So if you're buying data from an external vendor, you can write expectations about how it should behave and how it behaved in the past. And then if that vendor introduces a new code or, any number of things happen, the total number of people in the world goes down instead of up, or something that just shouldn't ever happen. You can look at that, or you can have some real clarity around what's happened in order to communicate back to the vendor.
Got it. Yeah, that makes sense, especially with these third-party data sets and folks integrating these from multiple sources. So one more, Andrew is asking, in the financial services example you gave earlier, would it make sense for the downstream systems to publish their expectations to the producing system?
Yes, indeed. We actually have a term we use for that. We call that a data contract. I think that's really a phenomenal case. In fact, with data docs, it becomes possible to publish the prescriptive version of an expectation suite in a readable form, put that up on a website, for example, make that available to them. But yes, also to actually share the expectation suite. I think that's a really good use case.
Got it. Awesome, great questions, and great to hear from folks in the community. So I just wanted to go back to any other clarification you wanted to, or if you wanted to dig deeper in the profilers, because I know I kind of interrupted you, during that section. Is there anything else in the profilers that are interesting for users to know, or are people building additional tooling around the profilers, or is this are they automatically kicked off, or is this something that's kind of a do it once and do it out of band, or how are people using the profilers so far? I'm just curious, just more color there.
Yeah, I think that's actually an area that we're likely to see some continued growth from community, and I don't think there has really emerged yet a standard practice for how that's done. In fact, Abe and I had a conversation just a couple of weeks ago in which we were both we sort of were sharing back and forth some candidate rules that we would have written, and I looked at his and I was like, I don't think I would. I think that should be an expectation suite, not a profiler. And he looked at mine and he said, oh, well, I don't know. I mean, I think that should be more automated. So we're still seeing it. I think just like with modular expectations, one of the things that we're really focused on is making sure that it's easy for people to express what they want with great expectations, and that we can position the library to become a tool that's ubiquitous, that people use to really describe what they expect. So the real key thing that I'd emphasize on profilers is that it's about composability. It's about the ability to express what you want and make that easier to experiment with, and then of course also for us to help people learn their data better. So I think I wish I could say that there is one profiler to rule them all, but I think it's also lovely that that's not the case, that there's so much opportunity for people to still compose and build.
Yeah, that's great. Well, I'm really excited to see how the community takes to these new features, and I'm sure you have even more goodness coming up this year. So it'll be an exciting year to track the GE community, and I can't wait to see how these things continue to emerge.
Thank you very much. It's been again been really fun, and I think there are some things that to kind of hint for a second at where I think we're also going, and I think it was Brian's question about these data contracts. One of the things that we really want to do is make it easier for people to have those collaborative conversations and engagements across teams and across organizations. So we've actually started working on building out some SaaS features around GE that will support those kind of engagements that are just really hard to do when you're working in the space of configurations and teams and right in your engineering pipeline. So I think that's what I encourage people to kind of look out for, and for us to, we'd love to engage with people on that to identify how we can best support those kinds of interactions and engagements.
Yeah, the collaboration across teams is so important, and it's gratifying to see how much it's come up in our conversation, because establishing a language and a process and sort of the edges where teams are able to collaborate with each other is super important. And we've seen that in the data council community over the years. We started off just as a data engineering community because that was sort of underserved, but then there's all these edges between data engineering and data science and the analysts, and then the business users who are sort of consuming the analysis. And so I like how you guys are sort of going for this collaborative model and trying to establish a baseline and common ground so that teams can start to work with each other on some of these hairy, thorny data problems. So.
Yeah, absolutely. Thank you.
Well, I wanted to ask you before we let you go, if you have any advice for others who are thinking about starting a data-oriented company. Is open source the way to go? Would you? I mean, obviously that's the road that you guys chose with GE, and that's maybe circumstantial, or maybe that was the universe, sort of putting in your lap. But do you have any advice for other engineers or analysts out there, data scientists in our community who might be thinking about starting a data-oriented company?
I think going way back to where we started this conversation, for me, I've always been passionate about improving our ability to understand something and having a core problem in mind. So I think the things that I find most exciting, the kind of tooling that I have found most exciting, is where you're addressing a need that's tied intimately to a business problem or an analytic problem. And one of the big changes that I see happening that's driving this next generation of change in the data ecosystem is the much tighter integration of data production and consumption to business units. There's much lower barrier now for every analyst to be able to look at and create data sets, which has created these incredible benefits and therefore the need for communication that we're addressing with Great Expectations. But there are a raft of other related problems, and I think being tightly tied to why whatever the human aspect of the data system is the thing, at least for me, that's what I find most fascinating, and I think is just so important not to lose sight of.
Yeah, that's well said. And what surprised you most about your work in the data ecosystem so far? Maybe apart from sort of the importance of the human element, is there anything else that really stands out at you that you didn't expect?
I think the level of community engagement I couldn't have anticipated. I was thinking, oh, well, we'll offer up Great Expectations and it'll be done. Data scientists will put it in the front of their notebooks, and data engineers will put it into their pipelines, and sort of the world will be good. Never could have realized that there are just so many smart people out there who are willing to participate in building something so impressive. I think, for example, we've gotten multiple integrations with other DAG runners, with alerting systems and tools. People have written integrations with different storage backends for storing and accessing expectations. And there are just, the world is full of incredible people. So I just can't always get excited about that. And it's really fun to see that in practice.
Yeah, that's great. It's great to see the community, bond together around some of these projects, and really appreciate them and offer feedback and support and guidance usage. It's tremendous to be able to. We live in a really amazing time in the open source world where we're able to build these projects in full view, and with digital community tools like Slack and others to get information distributed immediately. It's quite rewarding to build a company sort of out in the open, and I think you guys are a great example of how to do that best.
Thank you very much.
Yeah, thanks for joining us, James. This was a really fun conversation, and it was really awesome to be able to chat with you for an hour.
Absolutely. I've loved it as well. And thanks for putting this together. And again, I think bringing so many people together, it's really fantastic.
Yeah, it's our pleasure. And to the community out there, thanks for joining us this episode. We hope that you enjoyed it. You can sound off in the comments. There's a comments link in the YouTube chat. If you let us know how we're doing, we really appreciate it so that we can continue to make DC Thursdays more beneficial and valuable for the community. Also, if you're an engineer founder who's looking to get your own company off the ground, I've been offering office hours the last few months, and it's been really rewarding for me and hopefully for the community as well. So we'll put a link in the chat if you'd like to avail yourself to one of the office hour sessions that I have coming up. I love to talk to technical founders about starting their own companies and how we can best support them using the resources that we have and the amazing experience that we have here in the Data Council Network. Finally, don't forget to subscribe so that you get notifications for future episodes. And we're looking forward to our next event on February 4th, where we're having Bar Moses from Monte Carlo, who'll be our guest. So make sure you tune in then, and I'm sure Bar will have some interesting perspectives on data monitoring and data quality as well, since it's such a hot topic in the space right now. So thanks again to James and all of you, and we'll see you next time.